Hi and welcome to electrical engineering projects. In this video, we will see a closed loop control of a buck converter. And as we can see on the screen, the converter has a DC input, switch, diode, inductor, as well as output capacitor in the load. So to check the capability of the user controller, which is PI controller in this case, we will test the converter operation under two conditions. In the first case, we will see uh, the operation under variable load conditions, and for that we will change the output or the load resistor value, as we can see indicated by the signal, will change from around the 2.56 up to 3.2 at 7.45 seconds, and then we will change again the value to 3.81 ohm at around the 1.25 seconds. So under these variable load conditions, the controller should stabilize or control the output voltage at a specific set point, which is chosen to be 16 voltage in this case. It can be any value, but here for this converter, it was chosen to be 16. And in the second condition, we will keep the load constant or the output resistor constant, and we will change the input voltage in different steps. So we'll change it from 20 to 30, or will increase the input voltage. So under these varying conditions, the controller should keep the output voltage constant, and they will see the operation in the scope regarding how it will control. So let's see the simulation. Okay. As we can see here, at in time t1 in the first, it begins with 2. The load starts with 2.56 ohm, and then it changes at time t1, which is here. It increases to 3.19, and at t2 again here, it increases to 3.81. Under this variable load conditions, as you can see here, for the output voltage is constant under the variable load conditions. However, the current is varying. As you can see, it is decreasing. This is because from Ohm's law, we know that if the voltage is constant and the I is V by R, so if R increases, the current is expected to decrease. So it successfully controlled or the output voltage at the required set point, and it is very fast, as you can see from the steady state. So let's check again the another condition, which is variable voltage. This should be variable input condition, and we will keep this one constant at certain value, whatever it is. Okay, hopefully it is right. Let me see, 2.59, 2.59, 2. Yes. So now the load is constant at 2.59 ohm, and the input voltage will be changed in a step from 20 to 30 in 1 second. So before it was 5, but the simulation time was 2 seconds, so the change was not noticeable. Now it is 1 second, so 50% of the simulation time, the voltage will be increased from 20 to 30 volt. And let's see how the system responds to this input change. So as we can see, the voltage increased from 20 to 30. The output is constant. However, the output voltage is kept constant. This means the voltage, the output voltage is well controlled within the PI controller at the set point, despite the change in the input. We can see here there is high oscillation or uh, high ripples in the inductor, which is coming from the change in voltage. So that's all for this video. We'll see you in the next video. If you need this model, or if you need to understand the detailed simulation, you can contact me in my personal email here, and I will try to send you or discuss with you whatever assistance you need.